All right, so like I said, like I told you guys, this is the last section of notes for this chapter, quadratics. So it's going to look very similar to what we've been doing. It's going to look very, very similar to what we've been doing. The only thing is there's always little new things that are added in. So today is a combination of what we've been doing, because the steps on the board, the steps on the paper are exactly the same as we've been doing. It's a combination of that, and it's a combination of what we did the last couple days with um, with imaginary numbers. So it's kind of a combination of both. Okay. So like you can see, the steps are the same. The steps are exactly the same. Set equal to 0. Make sure it's in standard form. Factor out a GCF if you can. If you can't, don't worry about it. ABC. Then we try the X. If that works, use that. If it doesn't work, we got to go right to the quadratic formula. Okay. If it does work, you continue on to step 5, 6, and 7. But if it doesn't work, quadratic formula. Those steps are the same, but what we see will be a little different. Okay. So let's go to example number 1. Example number 1. What are the roots? It says, what are the roots of the equation? Roots are the same thing as x-intercepts, same thing as zeros, same thing as solving. So this says solve the equation, but it uses roots as it. So all we're doing is solving. Okay, like I told you guys, they'll say it different ways, but it means just solve. Okay, so for solving, I'm going to do what we've been doing. Okay, so let me rewrite it. X squared minus 6x plus 45 equals 0. Okay. First step, set it equal to 0. Needs to be in standard form. It's already in standard form, and it already equals 0. Check. Step 2, factor out a GCF. So is there a GCF between the 3 terms here? This guy, and that guy. Or is there a number I can divide them all by? Is there something I can divide them all by? Between this guy. No, it doesn't look like it, right? Doesn't look like it. Besides 1. Okay, skip that step. Let's go to ABC then. Okay, so A is 1, B is negative 6, C is positive 45. Okay, so multiply to be 45 and add to be negative 6. That's what I need to find. Okay, so I need to make a list of all the numbers that make 45. There's not many. 45 and 1, 9 and 5, 15 and 3. I think that's it. Well, when I add those guys up, this guy, and this guy, none of them make negative 6. They don't even make negative numbers. They make positive numbers. Well, I can change that by putting negatives here because it still makes positive 45. But even then, if I add them together, this one makes negative 46. This one makes negative 14. This one makes negative 18. That doesn't make that, right? So that doesn't work. So we have to use quadratic formula. That's why we have quadratic formula. When things like this, when it doesn't work out the way we want it to. Okay, so I'm going to set up the quadratic formula. We've done this before. Quadratic formula, -1 times b plus or minus the square root of b squared minus 4 times a times c. And then 2 times a on the bottom. Okay, we've done this before. Plug in a's for a's, plug in b's for b's, plug in c's for c's. So a goes here and here. B goes here and here. And then C only goes one spot. There. Okay. All right, so when we multiply -1 times -6, I get +6, plus or minus. And then I have in the square root. On the bottom, I get 2. 2 times 1 is just 2. So -36, -6 times -6. Remember, that's not like this. It's like this. -6 times itself. We want a positive answer. So -6 times -6 is going to be positive 36 minus -4 times 1 times 45. Let's see here. -4 times 1 times 45. I get -180 minus 180. Okay. 36 minus 180. It's going to be a negative number. 36 minus 180. -144. I didn't do anything wrong. I just got a negative number. We've never gotten negative numbers there when you were supposed to. Before we said it was wrong, right? Well, our next step was put it in our calculator, right? When we had things like that, we said, oh, put it in our calculator. So 6 plus, division. 6 plus the square root of -144. And on bottom, I get 2, right? My calculator freaks out. My calculator says, nope, I can't do that. Why can't I do it? What's wrong with that? What's wrong? It was doing that. It was working before, right? When we did it in last week, it was working. It gave me an answer, right? Usually a decimal. What's wrong with the stuff we have today? Negative square root, right? Negative square roots. Well, we talked about that not yesterday, but Friday, I believe, right? We talked about negative square roots. When it has a negative square roots, what do we have to add in there? An I, right? That's what we're going to do today. So what I'm going to do here is I'm going to say 6 plus or minus. What is the square root of -144? Well, if the square root of -16 is 4i, and the square root of -81 is 9i, and the square root of -100 is 10i, what's the square root of -144? 12i. No more square root. Okay. I still can't plug it into my calculator because my calculator has no idea what I is. My calculator has no conception of what imaginary is. So I have to figure out another way. Okay, so look up here. It says, if your answer, this part I skipped, it said, if your answer are complex, means they have an I. Complex means you got an I. Use this form here. Okay, so remember, A is the real part, BI is the imaginary part. So let's go down here. We got to separate them. Oops. Let me highlight them. 6 is a real number. 2 is a real number. 12i is imaginary number, right? So what I have to do is, this means division, right? This means division. Both of them, real and imaginary, are being divided by 2. So what I'm going to do is I'm going to write it like this. 6 divided by 2 plus or minus 12i divided by 2. When I do that, it allows me to separate them. Now, this part is my real part. This part is my imaginary part. They're separated now. Okay? You can split them up even further because you can give one a plus and one a minus. Okay? Last thing, if you can, reduce, always reduce your fractions. So 2 goes into this guy 3 times, 2 goes into that guy 1 time. So I have 3. Same thing over here. Same thing over here. 2 goes into this guy 6 times, 2 goes into this guy 1 time. So I really just have 3 plus 6i as one of my answers. And I have 3 minus 6i as my other answer. 2 separate answers, 2 boxes on Delta Math. Just like that, you're done. Both answers have a real part, 3, and an imaginary part. One of them has a positive 6i, one of them has a negative 6i. Okay? Those are the roots. Okay? All right. Okay, so turn it to number 2. Flip it over or open up your book, however you have it. Okay. Okay, so what are the roots? So in other words, solve the following equation if your roots are complex. So if we have a negative, how do we know if they're complex? If I get something like this, if I get a negative under here, it's going to be imaginary. Okay, so if I have that case, it said do like you did before. Separate them by real and imaginary. Okay, so step 1's the same. Let's start with step 1. Step 1 said, let me rewrite the problem first. Set equal to 0. Okay. We've done this many, many times before. Add 30x to both sides. So 9x squared plus 30x plus 29. I can't add 30x to any of them because they're not like terms. So I just put it in the middle because now it'll be in standard form. Okay, step 1 done. Step 2, factor out GCF. Is there a GCF here? No, right? 9 and 30 can be divided by 3, but 29 can't. 29 looks like it can be divided by 3, but it can't. So I don't have a GCF. Okay, so let's go on to the next one. A, B, C. A is 9, B is 30, C is 29. Okay. So I need to multiply 9 times 29. I believe it's 200 something. 29 times 9, 261. And they got to add up to be 29. No, sorry, 30. This is where my calculator comes in handy. So this is what you're going to do, either on Delta Math or you can do it on Desmos. It's the same type of calculator. You put the number 261 divided by, and then you just start dividing it by things. Divided by 1, or sorry, by 2. No, it doesn't go in evenly. 3. Yep, 87 and 3. Okay, so let me write that down. 87 and 3. 4. No. 5. No. 6. No. 7. No. 8. 9. There we go. There's another one. 29 and 9. Forgot to write itself in 1. Okay. 10 won't go in because it doesn't end in a 0. 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 7, 8, and then 29 obviously goes in because I already. So I think that's about it. 87 times 3, 29 times 9, 261 times 1. They got to add up to be 30. None of them add up to be 30. 29 times 9 is 38, but it's not 30. So it doesn't work. So if it doesn't work, our only option is the quadratic formula. Okay, so let me set it up. A goes here and here. B goes here and here. C goes here. Okay. So let's see. Negative 30 plus or minus. I get 18 down here. 30 times 30 is 900. Negative 4 times 9 times 29. Negative 1044. Okay. So negative 30 plus or minus the square root of 900 minus 1044. It's actually going to be negative 144 again. It's not always going to be negative 144. You might get other things. So just because it's been twice, just coincidence. Okay. So we get negative 30 plus or minus the square root of negative 144. Well, the square root of positive 144 is 12. So the square root of negative is going to be 12i over 18. Since it's got an I, they want me to split it up, just like I did earlier. So both divided by 18. Split them up again because one's got a plus and one's got a minus. So actually, let's reduce right now then. So both of these guys, 6 can go into both of them. So I get a negative 5 on top and a 3 on bottom. 6 goes in here twice. 6 goes in here 3 times. So I get negative 5 divided by 3 plus 2 divided by 3. The I can go on top with the 2, or you can put it on the side. That's okay too. The only place it can't go is on the bottom. It's not allowed to go on the bottom, but it can go on top or it can go on the side. Either one's okay. Okay. There are my two answers. Negative 5/3 is my real part. 2/3 I is my imaginary part. 2 boxes. You were okay. All right, so now I want you to do example 3. Try example 3 now on your own. Do example number 3. Okay, so it's already equal to 0. There is no GCF. I can divide 9. 9 goes into 9, and 9 goes into 54, but it doesn't go into 85. 3 goes into 9. 3 goes into 54, but 3 doesn't go into 85. So nothing goes in. So when I do x, the x, it's going to be a big number. It'll be 700 and something. No, not 79. What was it? It's 85. 9 times 85. 765. So I got to come up with the two numbers that multiply to be 765 and add up to be 54. Well, here's the thing. You can do that. You can say, okay, divided by 5, divided by 15, divided by 25 maybe, 35 maybe. Or you can just say, you know what, I don't really, that's too hard. Not too hard, but that takes too much time. You can always go straight to the quadratic formula. You don't need for this not to work in order to go on to the quadratic formula. If it doesn't work, you have to go on to the quadratic formula. But you can always just go right to the quadratic formula. If it's just big, ugly numbers and you're just like, I don't want to try this, go right to the quadratic. Okay, go right to the quadratic. It's not wrong. Quadratic always works. It's always, always, always works. So 65, 765, let's see. 5, so 153 and 5. 765. 5 and 153. Let's try 15. 51 and 15. Trying things that end in 5, or because that's most likely what it's going to be. 25, no. 35, no. 45 and 17. 55, no. 65, no. 75, no. 85, no. Or yes, 85, yes. 85 and 9. 95, nope. 105, 15, 25, 35. Getting to a point where I don't think I'm going to have any more. The ones I have, none of them add up to be 54. The closest one I think is 17 times 45, which is 62, but none of them there. Okay, so let me go to the quadratic. -1 times b plus or minus the square root b squared minus 4ac over 2 times a. Okay. B goes here and here, A goes here, and C goes there. Okay. Let's see, 54 times 54. going to be a big number. 2916. 2916. -4 times 9 times 85. -3060. Okay. When I subtract those two numbers, I get -144. It's not always going to be -144. It's just coincidence that I'm getting -144 on these guys. Okay, when I subtract 2,916 minus 3,060. Okay, so I get -54 plus or minus 12i over 18. Okay, separate them. -54 divided by 18 plus or minus 12i divided by 18. Okay, reduce. You can reduce both of these guys by 18. 18 goes into both of them. I believe, let's see, 54 into 18. 54 divided by 18. Yep, 3 times. So -3 and 1. And then these guys you can divide by 6. So you get two answers. -3 over 1 plus 2/3 I. And -3 minus 2/3 I. Okay. Okay, so you have the real part. The real part is -3 for both. Imaginary part's different. One of them is positive 2/3 I, one of them is negative 2/3 I. Okay. All right. Okay, so last part. Last part. Something called the discriminant. The discriminant. The discriminant is part of the quadratic formula. Which part is it? It's the part underneath the square root. It's only the part underneath the square root. B squared minus 4ac. So using the discriminant, that's called the discriminant, we can tell one of three things. We can tell if it's positive. Greater than 0 means positive. So if that number is positive, that means we have two real answers. So that means we have two roots that are real. It crosses the x-axis in two spots. Now they might be rational or irrational. I'll explain how to do that in a little bit. If we get a discriminant of 0, it means it doesn't cross, it only touches. It only touches the x-axis at one spot. We get one answer, but it's repeated. Means the two answers are the same, they're equal. Or if the discriminant is negative, less than 0, it doesn't cross at all. We still get two answers, but they're both imaginary. They're both imaginary. Kind of like how we've been doing. Okay. All right. So rational numbers. Rational numbers can be written as fractions. So whole numbers are rational. Integers. All integers are negatives. Negative whole numbers. Terminating decimals, 0.5, 0.25, 0.4, things that stop. Irrational. Irrational are the things in your calculator that never repeat and never end, right? Those are the things that are irrational, okay? So let's do number 4 together. Let's do number 4 together. So we don't actually have to solve number 4. We just have to use the discriminant to tell me what type of answers I'm going to have. The nature means what type. What type of answers are you going to have? You don't need to give me the answers. I don't need the answers like you've been doing. I just need to know what type of answers you're going to have. Okay? Here's the thing. We use the first two steps, though. We still start with the first two. We just stop there. So the first step is set it equal to 0. Needs to be in standard form. Done. Step 2, factor out a GCF. The leading term needs to be positive. That's where we need to do. The leading term is not positive. The leading term is not positive. The leading term is negative. So to make that a positive, I need to divide everything by what? Negative 1. So negative 1 goes in front. We've done this before. So that changes it to positive x squared minus 4x positive 2 equals 0 still. My focus is still in here, though. Okay, so now use the discriminant. The discriminant is only this part right here. B squared minus 4 times A times C. Okay. Well, I know that A is 1, B is negative 4, C is positive 2. So the discriminant is B squared minus 4AC. B squared minus 4 times A times C. Okay. B is 4, negative 4. So I'm going to put negative 4 in here. A is 1. C is positive 2. I want to know what type of answer I'm going to get. Okay, so I got to figure it out. Negative 4 squared. Remember, negative 4 squared, that's what this means. Not this guy. Negative 4 times negative 4 is positive 16. Minus negative 4 times 1 times 2, negative 8. So when I multiply those, I get negative 8, or positive 8. All right, so on the table, we got to figure out where 8 falls. Where does 8 fall? In the green, in the orange, or the purple? Where does 8 fall? Well, 8 is bigger than 0, right? It's positive. So it's going to fit in the green. So that means I'm going to have 2 real roots. I'm going to write that down. I'm going to have 2 real answers. 2 real roots. The only other question they're going to ask is, are they rational or irrational? This is how you tell. Well, this part here, the discriminant is underneath the square root, right? So what would the square root of 8 give me? Something rational, pretty, nice, clean, or something long decimal? The square root of 8. It's going to give me something ugly, right? Square root of 8. 2.8248, blah, blah, blah. My calculator doesn't repeat and doesn't stop. Or it stops at 5 because it's tired of writing numbers. But that number is what we call an irrational number. So we go back and we say irrational. Done. Okay. Let's do example number 5. Example number 5. Same thing. Use the discriminant to find the nature of the roots, the type of answers. Okay. All right. Well, this one's got a GCF. I can divide all of them by 2. So we get 2x squared plus 12x plus 36. Okay. A is 1, B is 12, C is 36. So I'm going to plug it into the discriminant. Figure out what type of answer I'm going to get. B squared, 12 squared, 4AC. Okay, so square, that's going to give you 144, 12 squared. Negative 4 times 1 times 36. Negative 1 times, oh, sorry, not negative 1. Negative 4 times 1 times 36 gives me negative 144. I get 0 as an answer. Okay. So I go to my table. Green means positive. Yellow or orange means 0. Pink, purple means negative, less than 0. Well, this time we got it to be 0. So that means I'm going to have one repeated root. It means I'm going to have one answer, but it's going to repeat. Okay. One repeated root. Is it going to be rational or irrational? Well, the square root of 0 is 0, right? That's rational. 0 is a nice, clean number. Rational. Done. Okay. All right. I want to give you one more like that because I want to show you what you're going to see on the assignment tomorrow, the practice assignment tomorrow, and then also your test when we eventually take it. This is the type of question you're going to see. Number 6. It's a multiple choice question. Which of these are the types of answers you're going to get? Okay. So I want you to do this one last question in your notes, then we'll tape it. Okay, so they got a GCF of -4. So you divide them all by -4. So you get x squared plus 2x minus 22 equals 0. Okay. So we got A is 1, B is 2, C is -22. Okay. B squared minus 4 times A times C. So B squared minus 4 times A times C. Okay. So 2 squared is 4. Minus. And then you have -4 times +1 times -22. So it's going to be a positive 88, which is 92. The discriminant is 92. Okay. So we go to your table. 92 is bigger than 0. It's positive. So that means I'm going to have 2 real roots. 2 real roots. Okay. So let's start ticking things off. Anything that says doesn't say real, I'm crossing off. Imaginary. Nope. Can't have imaginary. So I have, let me do irrational or rational. So 92. 92. If I find the square root of 92, that's not going to be a pretty number. Square root of 92 is irrational. So the only one that works is that guy right there. Equal means repeated. It means you're going to have real, but they're going to be repeated. So equal means repeated. Okay. Unequal means 2 roots. Unequal means 2 roots. So the difference between the second two are just rational or irrational. Okay. And that's it. All right. Okay, so tape is in the back. That is the last.